Good evening, ladies and gentlemen, lovers and seekers, those who are lost, and those who are found. Tonight I will be reading from the compilation titled, Outlaw Creative, The Geometry of Life. We will be hearing from the chapter titled, Curvature Without Equations. That being said, let's get started, shall we? Curvature without equations. What general relativity is actually saying? Forget math for a moment. Imagine this instead. You are standing in space with no gravity anywhere. You release two metal spheres next to each other. They float. They remain the same distance apart. Nothing surprising happens. That is flat geometry. Now imagine you are near Earth. You release the same two spheres side by side. They both fall. But something else happens. They drift slightly toward each other as they fall. Not because one pulls the other. Not because they collide. But because both are falling toward the same center. That difference, that slight change in separation, is the physical meaning of curvature. Gravity, in Einstein's theory, is not a pulling force. It is the shape of the stage on which motion occurs. The rubber sheet analogy, fixed properly. People talk about the rubber sheet with a bowling ball in the middle. It's crude but helpful if cleaned up. Imagine a perfectly flat rubber sheet. Roll a marble across it. It goes straight. Now place a heavy bowling ball in the center. The sheet dips. Roll the marble again. It curves inward. The marble is not being pulled sideways. It is simply following the new shape of the surface. That's curvature. Now here's the critical correction. In real spacetime, there is no downward dip. The curvature is internal to space and time. And time curves too. That part is essential. Why time matters? Here's the part that matters most. Mass does not just curve space. It slows time. Near Earth's surface, clocks tick slightly slower than they do in orbit. This is measurable. GPS satellites must correct for it. So what is gravity really doing? It is changing how fast time flows at different locations. And when time flows at different rates in different places, motion naturally curves. Objects follow the fastest possible route through spacetime. And if time runs slower deeper in a gravity well, motion bends toward that region. Not because of force, because of geometry. What curvature really means? Curvature means this. The rules for straight are no longer uniform. On a flat table, the straightest path between 2 points is obvious. On a sphere, the straightest path is an arc. On a curved spacetime, the straightest path may look curved from outside, but to the object moving along it, it is not turning. It is simply following the structure. Gravity is structure. Tidal forces, the only gravity you can't escape. Here's the most important idea. You can eliminate gravity locally. If you are in free fall, in an elevator dropping toward Earth, you feel weightless. Inside that small falling box, gravity vanishes, but only at a point. If the elevator is tall enough, something remains. The top and bottom of the elevator fall slightly differently. The separation changes. That change cannot be removed. That change is curvature. So gravity in Einstein's theory is not feeling heavy. It is the difference in motion between nearby paths. It is geometry stretching and squeezing. The stretch-squeeze pattern. Near Earth, curvature does something very specific. It stretches objects vertically. It squeezes them horizontally. That's why tides happen. The ocean isn't pulled upward. It is responding to differences in gravitational influence across distance. Curvature is not about acceleration. It is about variation in acceleration. That variation is the fingerprint of curved spacetime. Why this is so radical? Newton said, mass pulls mass. Einstein said, mass changes geometry. The geometry then determines motion. It removes force from the picture entirely. Nothing reaches out and grabs anything else. Objects simply follow the structure. That's elegance at a brutal level, a cleaner mental model. Think of spacetime as a system of rules. In flat space, those rules are uniform. In curved space, the rules vary from place to place. When the rules vary, trajectories change. Curvature is rule variation. Gravity is rule variation in space and time. Why this connects to my curvature obsession? I'm drawn to curvature because curvature implies constraint shapes outcome. No invisible hands. No moral drama. Just structure governing path. In relativity, motion obeys geometry. In life, behavior often obeys structure. Where structure bends, paths bend, not because of force, because of configuration. The core insight. Here is the sentence that replaces all the math. Gravity is what happens when space-time is not uniform. Everything else is elaboration. Curvature is the non-uniformity. Tidal force is the evidence. Motion is the consequence.